All right. So when we think about the search for life, we had said, if you go, they're looking on Mars to see if there's any evidence that life is there or ever was there. And they're looking for carbon dioxide, among other things. So carbon, to see if there was enough carbon there. And then the other thing they're looking for is water. And I think they found some ice, right? Frozen water. So it ends up, we had said, remember we had said, those carbohydrates, it's a carbon with some water. And we had said that, and water, and then when we talked about breaking down any of these biological macromolecules, we had said, what do you produce as a waste? CO2 plus water. So water is essential for life also. So not only do you have to have the carbon, you need the water as well. Now, water is a weird molecule, very weird. I already talked about it breaking apart and, producing acid. But in addition to that, water I'd said it's made up of two hydrogen atoms, and we'd said they have one proton each in their nucleus. And then the other atom that's there is oxygen. And oxygen has 8 of those positives. So what happens, and I'd said, between the oxygen and each of these two hydrogens, there will be a pair of electrons that's being shared. And so those 2 electrons that are shared between each of the two hydrogens, each hydrogen has a pair that they're sharing. Well, those electrons, they can go down towards the oxygen, where there's 8 of those positives, or up to the hydrogen, where there's only 1. And I had said that electrons have energy and they're attracted to the positives, right? And so if you say, well, given a choice, and it's not really a choice, it's a physical phenomenon, but because there's more positives at one end by the oxygen than up by the hydrogen, they just spend more time down there. Positives and negatives attract. More positives have a greater attraction to the negative than just the one positive. 8 positives have a greater attraction than 1 positive. And we had said each of the 2 hydrogens only have 1 proton, whereas the oxygen has 8. So what does this mean with regards to water? And we all know about this first thing. There's something called cohesion. Co means to yourself, and hesion means sticking, right? So water sticks together. And so water beads up, right? So what does this mean? That means that on that water molecule, because the electrons are spending more time at one end of that molecule than at the other, that means you have a more negative end and a less negative end, positive end. So a partial positive and a partial negative. They're not always down there at that down by oxygen, but they spend more time down there than up here by the 2 hydrogens. And so as a result of that, we have a weak attraction between water molecules. The water, one end of the water is slightly negative, and the other end is slightly positive, so they kind of stick together. And that is called cohesion. Something like gasoline does not. And so what does it matter? Well, it means that it takes a lot more energy to separate those molecules. If you boil water, it takes a lot of energy to boil water as compared to boiling gasoline. Don't try it. Do not put gasoline on your stove and heat it up, because first of all, you'll be filling your house with gas vapors because it'll evaporate very rapidly because it doesn't stick together. Water does. Water is cohesive. Also, you may have seen a magic trick, or I think of it as a magic trick, when you go to have blood, your finger pricked. Sometimes you go to the doctor and they take that little teeny tiny knife thing and they poke a hole in your finger, and they take a little teeny tiny glass tube, and you got this puddle of blood there, and they stick the glass tube into the puddle of blood, and all of a sudden, the blood goes up inside of the tube. Why? That's going against gravity. But it ends up that glass has charges on the inside of it, and the partial charges in the water in your blood is attracted to the inner surface of the glass. And so capillary tubes, they use what they call a capillary tube to collect a sample of blood, and it looks like a magic show. You'd say, well, I'd pay good money to see that. Maybe not. But anyway, it's something called adhesion. The attraction of water towards some surfaces, like the inner surface of that capillary tube piece of glass. Okay, and now that is, do you know what? That is important for life as we know it. It is. It is. So think of an oak tree out there, and you got water in the ground, and at the top of that giant tree, you've got leaves that are going to be going through photosynthesis and using the carbon dioxide from the atmosphere and the water from the ground to build, sugar molecules, to build organic molecules. How does that water get all the way up there? Well, I'll tell you how. It ends up, there are little teeny tiny tubes inside of that oak tree that are like that capillary tube. And the attraction inside of those little teeny tiny tubes, plus some other forces like evaporation from the top, produces this movement of water up that giant tree all the way to each of those leaves. It's remarkable. So adhesion is important for life as we know it. Another really weird quality of water. Water is very weird. It ends up, so when we talk about different states of matter, we had said, you got your solid, we got your liquids, and we got your gas. And in most molecules, that means solid, the molecules are really close together. Liquid, they're a little further apart. Gases, they're really far apart. For almost everything, that's true. Not water. It ends up that cold water has molecules that are closer together than crystal solid water. They're slightly further apart. And yeah, then you say, well, that's an interesting point of trivia. I'll make sure and keep that in mind if I'm on Jeopardy, right? But it's actually important for life as well, because in any other kind of a molecule, the more dense you are, the heavier you are. And so if ice was like that, when the solid formed in the lake, it would sink to the bottom. But that isn't what happens, right? It's less dense than cold water, so solid water floats. Ice floats. It allows the fish would be pushed down into the mud. You couldn't have life under the ice if this wasn't the case. So it's a really important trait. Water is most dense at 4 degrees centigrade. Now, there's that would be almost, it's about 37 or 38 degrees Fahrenheit. So cold water is the most dense, and then solid is less dense than that. Okay, what else? Okay, so, and it takes water. Okay, one other thing. I'd said it takes a huge, water sticks together, so it takes a lot of heat to make it evaporate. And so what that means is water holds on to heat and very slowly releases it. So water, it takes a lot of heat to cool the water off, and it takes a lot of cold to pull the heat that's stored in water out. So what it does is it makes our world not fluctuate like you have out in outer space. I saw an interview recently with an astronaut who was talking about how the temperatures in space. And so when you are in space and not in the space station, but if you're, out wearing your space suit, out doing some work, the side of your body that is facing the sun is about 400 degrees Fahrenheit. Very hot. The side of your body that is away from the sun is like minus 400 degrees Fahrenheit. So, and it's because they're in a vacuum. So there is no atmosphere out there. And so you have this giant fluctuation in temperatures. So you're cooking on one side and freezing on the other side simultaneously. That's why it needs that spacesuit. And so because our world is dominated by water, it helps to keep our world within a range of temperatures within which life can survive. Okay. All right. So that is high heat capacity. There's something called high heat of vaporization, and that's the requiring a lot of temperature to evaporate water. And a high heat capacity means that it can hold on to a lot of heat. All right. We're going to come back and we're going to be talking about photosynthesis, yes, next time.